Ma'am, you're mute.
Good morning, respected Motiwala sir, our guest, Dr. Dheeraj Kalra sir, teachers, and my dear interns and students. Today we are starting with the third day workshop program. I call upon the prayer group to chant the prayer.
ईश्वर मेरे में सर्वपरि परिपूरक है। ईश्वर मेरे लिए सर्वपरि परिपूरक है। उसमें अपनी संपूर्ण आस्था रहने दो, आस्था रहने दो, आस्था रहने दो।
Now I take the privilege to give you about the introduction of our guest speaker today, Dr. Dheeraj Kalra sir. He had done his bachelor in dental surgery from Nair Hospital Dental College, Mumbai, and post-graduation masters in dental surgery in public health dentistry from College of Dental Sciences, Devgiri. He is about to finish PhD in clinical research under UGC. Appointed at the panel for IMETTT MUHS for medical research and research methodology. Appointed at the panel for accredited speaker at Maharashtra State Dental Council. He is member secretary IEC YMT Dental College and Hospital. Member of IEC of YMT Ayurvedic College and Hospital, YMT Homeopathy College and Hospital, and for various other colleges he is working, and also for the Research Institute from the Government of India he is associated. He is proprietor of Biostats, a consultancy dedicated to research in biomedical sciences running since 2013. Consultant, advisor, and statistician for international universities at Dubai, Malaysia, Spain, and UK. He is awarded for best performance at Sanshodhana Workshop for Biostatistics held at Bapuji Dental College and Hospital in September 2012. He had also received many awards. He had attended various international and national state level specialty conferences since 2010. He has a total 46 publications to credit in various national and international journals. H index and I index more than 10, delivered more than 330 lectures at various research methodology workshops in various platforms. He holds Reader's Post and is currently working as in charge of Department of Public Health Dentistry and has 8 years of teaching experience. Thank you. Now I welcome Dr. Dinesh Kalra sir to give his webinar.
Yeah, thank you, ma'am. Am I audible?
Yes, sir.
Yeah, thank you for the nice introduction.
There was little disturbance. Sorry for that.
No problem. We will face technical issues when we are online. So that is fine. Yes. Yeah. Okay. So I would like to know, are all PG students there or few staff members also there? And what is the background? As in all are from homeopathy background? So all students are postgraduates? Or there are some interns or some graduates also? Am I audible?
Yes, sir. Yes, sir.
Okay.
You are audible.
Postgraduates?
Yeah.
Yeah.
These are the interns. Interns.
Okay, they are interns. Fine. Okay. Okay, fine. So yeah, we'll start with the topic. So the topics given to me for today's session is inferential statistics, followed by a group activity, and then computer assistance in data analysis. Okay, so these three things I'll be covering. Fine. So we'll start sharing the PPT first. Okay. Are my slides seen? Is the slide seen? Are they moving?
Yes, sir.
Okay, great. Fine. So yes, so because the topic is little bit, related to statistics, you may be scared. It's all maths and we don't understand maths. So we took biology and so we are becoming doctors. So that is not the case. So I'll try to simplify this topic as simple as possible. And you'll not realize that we have done the topic after the lecture. Okay, fine. So basically I would like one volunteer to be with the mic, to be unmuted. So any one student, you can just, be online from your phone or something, and you can interact with me. So who is the CRGS of this batch, or the scientific head, or the topper in the class? Anyone can do that. This will also be helpful for our group activity. Anyone, or should I pick someone? Chalo, be quick, fatafat. Anyone, you can just unmute. Chalo, be quick, fatafat. Anyone, you can just unmute.
Hello.
Yeah, audible, audible. Yes. So can I know your good name?
My name is Prapti Kalra.
Okay, great. Fine. So I'll call you the leader. Okay. I'm very bad at remembering names. Okay. Yes. So yes, I would like to know, have you all been ever exposed to any research? Have you done any research, or do you know what is research? I'm very sure today is day 3 of the research workshop. So you are now sensitized. You know what are various study designs, what is a survey, what is a case control, cohort. Okay. So yes, have you done this by yourself? Any one of you in your batch? If not, yes, you can take up a simple survey, take up a simple interventional study. You can try some remedy on some kind of patients, some kind of conditions, and you can see before after the effects. All this will help you in your building up a foundation, knowing what is research, and maybe many of you would like to go in for masters, MD. So there obviously you have to do a thesis, you have to do a research. Okay, fine. So the basics of research, if I say remedy A is better than remedy B, we'll just use the terms remedy. You can use any two drugs. You can take, for example, Naxomica, Rustox, whatever is there in your field. We'll just label it as A and B. Now I want to prove that A is better than B, or B is better than A, or a new drug A is as good as a gold standard B. So I am basically making a hypothesis. So what is a hypothesis? I think everyone now understands. A hypothesis is a statement. It's an assumption. Okay. So we are trying to test the hypothesis. So we will first say that there is no difference between drug A and drug B. And then if there is a difference, we will reject this statement and accept the alternate statement that there was a difference. Getting it? So this is the basics of research. This is how any study is done. So you know what is null hypothesis. So the statement of negation or no is called null hypothesis. It will tell that there is no difference between. You are able to see my slides? I am drawing something. So the statement of negation or the statement of no or negativity will be there in null hypothesis. So basically we are just trying to prove, should I accept this null hypothesis or should I reject this null hypothesis? Is the entire thing for inferential statistics. Okay, I'm just trying to test a hypothesis. Why are we trying to test this hypothesis? Because I cannot do the study among everyone in India. Is it possible? Half of India takes remedy A and half of them takes remedy B, and then we see the effects. Not possible. First of all, we are having limited resources, time, money, material, manpower. No one will be indicated to take remedy A and remedy B in such a large numbers. No one will give you consent to do so. Trials may go unethical. So we generally take few samples. We run the study on few samples. We observe them. We do experimentation or take a case control cohort, any approach. And then we try to generalize this or extrapolate this to the large population. There the word inferential plays a role. Inference means in English, it is to conclude. Inferential is to conclude. Conclusion of the statistics done from a small number of people. That is your sample size, maybe 20, 30, 40, 100, whatever sample size you are taking, to a large population base. So you are trying to extrapolate your results. You are trying to generalize your results. Now, the leader, can you tell me how many times can you repeat this experiment? If I have 40 patients, how many times can you repeat them? 100 times? Can you do the same medicine, give the same medicine to the same number of people?
No, we cannot.
Exactly. So mathematically, I want to extrapolate. I will assume that in mathematics, if I repeat this experiment 100 times, will my results cross the cutoff? Will I get the same results every time? If I am seeing, pain scale, suppose VAS score, it reduces, or maybe you are taking some COMDT index or some index you are taking, or maybe, some indices, any indices, depression scale or something. So is it going to change every time? Or because it has just changed once, do I believe the result? Just once could be by chance. Okay. So that all again is about inferential statistics. Getting it? So we are trying to extrapolate and repeat the experiment mathematically, statistically, and believe that if I am getting the results repeatedly every time, that means it is not just by chance, it is because the remedy works. So we are talking of p-value. So what is p-value? It's the probability of the experiment or the drug which works. Okay. Now, in doing so, there would be certain errors called type 1 and type 2 errors that we'll see again in detail. I'm just sensitizing you. This is my just introductory slide. Okay. So alpha errors, beta errors, power of the study, all these terms, I'll make it clear. Fine. Now, how many of you believe that you are forced upon to attend the research workshop? ये जरूरत नहीं है, क्यों करना है ये सब, हम तो clinician है. So we'll just be dealing with the patients. ये सब में क्या रखा है? How many of you believe? You can raise your hands. It's okay, no offense, no problem. You can be frank. How many of you think so? Many of you? None of you? Okay. Whatever is the case, even if we are a clinician, we are treating a case, we are adding to literature, we are adding to research, we are generating a new finding. Okay. So research methodology, biostats, everything is important to us. Do you know, just 5 years back or 10 years back, there was a big market of Nokia phones. Now how many of you have Nokia phones? Hardly any. Why Nokia failed? Can anyone tell me why Nokia has failed? Leader, any reason Nokia has failed?
Failures to update.
Very good. So it believed that its technology, uska software was the best, and Android was nothing in front of Nokia. But now the thing is ulta. People wanted connectivity, people wanted sharing, Wi-Fi connection, and WhatsApp and what else, social media and all, which Nokia did not provide. So it failed. The same thing may happen to you. If you don't upgrade yourself in research, the world is moving towards it, and you refrain, you set back and say ये मेरे लिए important नहीं है, so you will become history. No one will know you. Okay. So this is the latest trend in research. You have to keep yourself updated. Now, how many of you like maths? But still you took biology. You still becoming doctors. Okay, good. So you should not hate maths. And it's not maths, it's biostatistics. It's not only, mugifying or rectifying the formulae. It's basically applying logic towards the conclusions. That is what is called statistics. Okay. So why it is important? In every walk of life, basically it is very important. So if you are, a stockbroker, once again, I'm getting a call from some other workshop. Yeah, sorry. Okay. So in every walk of life, we have statistics or mathematics or figures to play with. So to a stockbroker, share market कितना ऊपर गया नीचे गया. So you are interested in learning numbers. Okay. For a person who is active on some social media, so how many likes and dislikes your posts are getting, again numbers. For a dieting person, how many calorie intake is done for the day, again numbers. The size of our gadgets, phones are becoming thinner, smaller, laptops are becoming thinner, smaller. So whether you like them or hate them, basically statistics, figures, numbers are always there with you. So what is statistic is data, datum, basically a piece of information or a counted or measured fact, but it is represented as a number, as a figure. Okay. We don't have datas. It's already data or datum. Okay. Now, John Grant was the father of modern statistics. So he gave the bills of mortality, morbidity. So all these are called health statistics or vital statistics. Now, statistics from a maths background. What do they do? From maybe MSc in statistics, if someone is doing, they will also collect the data. They will also present it in some form. They will also interpret the data. So how are we different from them? Because we deal with the data obtained from biological sciences, from life sciences, be it an in vitro study, be it a human study, animal study, anything, it is to do with life sciences. So biology, biological sciences. So the word is biostatistics. Am I clear? So we are basically applying the same principles of statistics, but our data has come from biological sciences. So is it different? Yes, it is very much different. It's not only tables and figures, it is logic. It is because we are dealing with actual patients. We are dealing with humans. We are dealing with animals. So basically, we are dealing with life. Okay. So it's not something to do with inanimate. It's very much animate for us. Now, signs of variation and signs of figures are the two important things we look into. So, do you feel that you are similar to your batchmate? No two humans will be similar. So, we all are different from each other. So, we are different because we have variations with us. And how much is the variation and how much people differ from each other is when we are trying to quantify it. So, the science of figures is also very important. Okay. So, epidemiology and biostats goes hand in hand. So epidemiology will give you the principles of study designs, how to collect data, so that we have seen in the previous workshop days. Now, epidemiology will collect facts, it will convert to figures. These figures will be analyzed, applied statistics, inferential statistics, all these will be applicable on that. And then we can convert this applying logic to a fact. So the fact would be whether drug A works better than drug B. How many people are ill around me? What is the prevalence of a condition? What is the proportion of events or deaths or happening or successful events happening in group A and group B? So all these answers will be given by application of epidemiology and biostatistics together. So why do we need statistics? To define what is normal. So if I say systolic BP is 120, diastolic is 80, who defines this normal range? It is seen in most of the people. Again, statistics has a role to do. So if I see that with 120 and 80 people have a normal healthy lifestyle and a heart function, so we define that to be normal. But in how many people should this be there, that again statistics will define. It's not just observation for one or two people. It will be an observation from lakhs of people, a large number of people. The second point on the slide, you can see to test the difference between the means and proportions between populations. So here, if I'm just hypothetically noting it down, that remedy A works better than remedy B, and the outcome is mean. Outcome is maybe some mean of a scale. So the initial mean was 5, The next mean became 3.1. Here the initial mean was 6, which became 2.5. So I can compare whether there was a difference in group A versus group B, or the difference after the remedy worked between the two groups. So that is called intergroup difference between drug A and drug B. I can also see proportions between two populations. So if the population A has success rate of 80%, if population B has a success rate of 75%, I want to compare this number 80 versus 75 to see whether success was more in group A or group B. Am I clear till now? Are we going slow, fast? Leader, you can take the feedback from your classmates.
We are understanding, sir.
Great. Okay. Now, we also would like to throw light upon association and correlation. So what is the difference between the two? We use in English the terms very interchangeably. Association, correlation in English means almost the same, but in statistics, it is different. So any takes? So are you able to see my drawings? I'm making something side mein. Okay.
Yes, sir.
Yeah. So this is called a 2 by 2 table. It's a 2 row and 2 column table. Are you able to see? 2 by 2. So 2 rows and 2 columns. Now, if I say that, there is a factor and there is a disease, I'm talking of, say, a case control study. So the disease could be lung cancer. Okay. And the factor could be, say, smoking. So the factor was there and the disease was there in majority, in a large number of people. The disease was not there when the factor was not there, again in a large majority number of people. So can I say that because of smoking, lung cancer happens? Yes. Are you able to see the boxes? So this I'm labeling as A, B, C, and D. So because there are more number of people in box A and more number of people in box B, I say that with this factor the disease is there, without this factor the disease is not there. That means there is an association between the two variables. There is an association between the factor and the disease as the outcome. Am I clear, everyone? Okay. Then what is correlation? So correlation means numerical association.
Excuse me, sir.
Yes.
So please explain once, sir.
Okay. So I'll repeat. Many people have joined, I think now. Yeah. So see, there is a box 2 by 2. So it's called a 2 row and 2 column box, 2 by 2. Okay. So if I say that, there is a factor in few people, it is positive, in few people, it is negative. So example is smoking, and the disease as an outcome, say lung cancer, positive and negative. So having lung cancer and not having lung cancer. So if I see a large majority of people in box A and box D, I label them as A, B, C, D. A, B, C, and D. So if I see, maybe 1,000 people who were smokers and also have developed lung cancer, but 500 people who did not smoke and did not develop lung cancer. So if I see large numbers of people in box A and D, does it support my hypothesis that smoking is associated with lung cancer? फैक्टर है तो डिजीज है, फैक्टर नहीं है तो डिजीज नहीं है. Correct? So this is the term we use for association. So the factor is there with the disease. The factor is seen commonly with the disease. So they are associated. They are linked together. This is called association. Is it clear now?
Yes, sir.
Yeah.
Yes.
Yes. But the box B and box C actually will go against my hypothesis. if you see closely, there would be certain number of people who will be smokers but did not develop lung cancer, say 5 people. There will be, say, 10 people who did not smoke but still have lung cancer. So B and C actually go ulta. They go reverse to my hypothesis, but that we'll see later on. For now, A and D are more important. They are supporting my hypothesis. They are showing that there is an association between the risk factor and the disease as an outcome. Okay, am I clear till now?
Yes, sir.
Okay, great. Now we'll go ahead with the next point, correlation. So what is correlation? Suppose I have one variable on x-axis and the other variable on y-axis. Both are numerical. So every patient will give me one value on x and one value on y, and I plot data of many patients. So what I can see is there could be a straight line which passes through most of the points, not every point, most of the points. Okay, this line is shown as an increase. So as x increases, y also increases. So there could be a possible positive correlation between the two factors or variables. As x increases, y increases. Hypothetical UG example. The more I study, so this is hours of study, the more marks I get in the exam. Hypothetically, ऐसा होता नहीं है. 100% पढ़ोगे तो 100 क्रॉस नहीं हो जाओगे. Just joking. So positive correlation. Or there could be a negative correlation also. For example, the more time pass I do on WhatsApp, number of hours, my marks keep on reducing. So as x increases, y reduces. So this is when we are talking of correlation. So it has to be numerical. But in English, we use the terms interchangeably. So from now on in research, please do not misuse the terms association and correlation. They both mean different. Can we go ahead? All the doubts are cleared? You are understanding, leader?
Yes, sir.
Okay, fine. To locate, define, and measure the extent of disease. So who is ill, when they are ill, why they are ill, what makes them ill. So basically, it's all exploration of descriptive epidemiology. To evaluate the efficacy of drugs. So how effective is my drug? How efficacious is my drug? How efficient is my drug or remedy? So to answer all these questions, again, we need statistics. And from a public health perspective, if you are planning some camp or some outreach program or some health program, you will evaluate those health programs whether it has met the population needs or not. So again, to evaluate health programs, we will need statistics. Okay, so we'll leave this. These are dental examples. Okay. Now next is the three terms, very important. So I believe many of you are interns, but you'll be doing PG. So you can make a note right away. This will be helpful in your synopsis designing later on. The word efficiency, when I'm stressing upon, you can see two F's in it. So it has finances to do with. Okay. So when I'm talking of, yeah, am I audible?
Yes,
Okay.
sir.
Yeah. So when I'm talking of finances, as in cost benefit ratio, cost effectiveness ratio. Okay. So suppose, a tablet of 5 rupees gives me relief in headache. The same relief is obtained by a tablet of 50 rupees. So what is more beneficial for a patient? A tablet of 5 rupees, obviously. So if the relief obtained or the outcome is same with the minimum inputs, so such kind of studies are called efficiency studies, basically to do with finances, costs. Now, when I'm talking of efficacy, you have to focus on two C's in it. controlled conditions. So in a controlled condition, what happens? The other factors are neutralized. We are just checking, suppose there is an antibiotic and in a petri dish, it is able to have some antimicrobial activity, wherein all the other factors are not there. All the other factors are not there. But in a human body, other factors would be there. There would be, other proteins and albumin and tissues and everything. So here we are just having a controlled condition and we are seeing the effect of just one antibiotic on one organism. That's it. So whenever you are doing a controlled conditions, use the term efficacy, not efficiency, not effectiveness or nothing else. What is effectiveness in a real patient, in a real world scene scenario? So when you are giving a remedy to a proper patient, actual patient, please do not use the word efficacy. We have seen many synopses and many objections come from the universities. So please avoid such. So in a real situation, use the word effectiveness. How effective is my drug or remedy? That is effectiveness. Am I clear? All the three terms, please don't misuse or interchange. Okay. Now we'll come to the statistics proper. So what are the types of statistics? Descriptive and inferential. So in descriptive, we'll just talk of samples. So suppose I have 100 people, 500 people with me and I have observed something. So I may take the mean and standard deviation of height, weight, BMI, blood pressure, whatever, heart rate, pulse, IQ, anything. So whenever I'm talking of numerical variables, numbers, we will take the mean and standard deviation. When I'm counting people, how many males and females were there in the population, how many people belong to upper socio income class, lower socio income class. So I'm counting them frequencies and out of 100 will be percentage. So this is all about descriptive. Only we are describing what was my sample. We are not trying to generalize or we are not trying to extrapolate. We are not trying to conclude or infer anything from that. So our study will stop at descriptive. How many of them were what and finish. But if I am observing some difference, we will be testing the hypothesis as I had earlier mentioned, A versus B. So remedy A versus remedy B, how effective it is. Is there a difference in the effectiveness in remedy A versus remedy B in curing so and so, using so and so index? So you can think of any index and any disease, any condition for that matter. We just spoke of association. So is the factor associated with the disease? Again, you need to prove. Suppose I'm seeing 100 cases of lung cancer and majority of them were smokers. Do I believe that the observation which was done in 100 will be there forever across the world? Every person who will smoke will get lung cancer or not? So is there association with this factor and the disease? That I have to prove using inferential statistics. I need to conclude my study from inferential statistics. Correlation. If I say that X increases, then Y also increases, but this is seen in say 500 people. So will this be always seen in 10 crore people, 1 billion people? So I have to again conclude or infer the conclusions, the observations done from few samples to a large population. This is called inferential again, but we have different types of inferential statistics. Again, regression. Now, what is regression? I'll just sensitize you to what is regression. Suppose if I write an equation y is equal to ax plus b. Leader, you are able to see?
Yes, sir.
Okay. So suppose y is the salary of an individual. X is the experience in years of an individual. B is a constant in the equation. ये हमने स्कूल में किया है. If you remember, we used to have, some as a slope and then intercept of x and y. So every unit change in x causes how much change in y. If you remember all that. Okay, fine. No need to, go back to school maths now. Just stick to this example. So yes, leader, if I give you the values, can you solve this equation? A has a value of 1000. B has a value of 20,000. So what is the salary of an individual with 5 years experience? Can you tell me? Anyone can prompt answer. Yes. Experience value I add here, keep as 5. So this becomes 5,000 plus 20,000 becomes how much? 25,000. Okay. So 25,000 is the salary of a person with 5 years experience. Hypothetically, so India mein hota nahi. Okay. Suppose X becomes 0. That means the experience was nil, fresher. So what is the salary?
20,000.
20 only. Exactly. So this is how we can predict. Even in biological sciences, we can predict y is equal to something plus something plus something. This could be age of the dead. In forensics, we will see certain anthropometric measurements, skull base, certain nerves, openings, foramen, all those things we would see, and we will substitute these values in the formula equation, and we can predict the age of the dead, generally done by forensics. In dental sciences, we have many such indicators for age. So if I believe that this much was the shift in the mental foramen or some skull base something, and I'm able to predict the age for say few people, 100 people. So will this formula work with many? Okay. So that is all about again inferential statistics. So you understood there are two types of statistics. I'll just quickly recap. This is all about your samples. So from the samples, if I obtain certain values, I'm just describing what was the mean, standard deviation, percentages, frequencies. But in inferential statistics, I want to extrapolate this to a large population. Am I clear? Yes. So I'll just take you to that slide. So inferential means you are making generalizations about the large group, but the data has been obtained from small sample size. So just see this slide. This is the basics of research, everything in one slide. So from this population, because we cannot study everyone, we take few people. This is sampling. The sampling I think has been done or would be done, I think, I don't know. So sampling techniques and sample size estimations. Now from this, on this small number of people, that is sample, we do the study. So study could be descriptive, analytical, experimental, anything, observational, any study we can plan, case control, cohort, cross section, anything. The results which we obtain from this small sample has to be extrapolated, has to be generalized, because unless I do so, I don't know what is happening in the population. Okay. So I'll have to, because I cannot study everyone, we took all this, we took samples and everything. So I have to go back and give the result to the population. So if drug A is better than drug B in 40 people, will it be always applicable in 10 crore people? This is all about generalization or extrapolation or inferential statistics. Am I clear till now? Everything is
Yes.
clear? Okay, fine. Leader, what was your passing percentage in UG for anyone?
74.
No, not your, as in passing percentage. 50%, 40%? 50% is the cutoff. We say it is passed after 50. Yes. But for a statistical work, for research purpose, our passing percentage is 95%. That means in more than 95% of the people, say I'm taking, to simplify this example, I'll take 100 people. The drug works more than 95 people. In more than 95 people, the drug works. I say the drug is successful. If it works in 94, I say the drug fails. Itna strict hai. It has to cross 95. If it works in 97, do I say it works?
Yes.
Yes, it works. Now this is actually not proportion or percentage, it's the probability. Now I'll take you to one more example. If I give the same drug to 100 people 100 times and in more than 95 times, so here we are converting to probability. In more than 95 times, the drug has shown the same result. Then I believe that the drug works. It's not actually percentage, it's the probability. So we should not directly talk of percentage. So did you understand? So mathematically, we are trying to repeat the experiment 100 times. And if the drug is giving the same result in more than 95 times, the probability of this increases. Then the probability of the drug being working is successful. Only then we believe that yes, the drug is successful or it works. Okay, fine. So we are basically talking of probability. So what is probability? The chance of the event happening. The chance that the thing will happen. Okay. So it goes from 0 to 100% could be the probability of an event happening. But in mathematics, in statistics, 100 is written as 1.0. So if I say the probability of the event happening is 0.65, it means that 65% is the chance that the thing will happen or the event will happen. If I say the probability of the event happening is 90%, I would write that as 0.90. Am I clear? So if I say the probability of the event happening is 0.9, what is the probability of the event not happening? 10%. 10% would be expressed as 0.10. So both should add up to 100%. That is 1.00. Am I clear? Am I clear, everyone?
Yes, sir.
Okay, great. So basically, if I say that it should cross the probability of 95, so in more than 95 times it should work. That means in less than 5 it may not work. Now we'll relook in a different aspect. In less than 5 it may not work. So 5 could be error. So it is error. It is by chance that it did not work. So I want to keep this error as low as possible. So it is less than 0.05. 0.05 is nothing but 5 upon 100. I want to minimize the errors. I want to reduce the errors. So I'm keeping less than 0.05. The error should be minimized. So have you gone through some articles? Do you know? Have you gone through what is p-value? In the article, they report always p less than 0.05 was considered to be statistically significant. Basically, we are talking of the same. So what is the chance? What is the probability that the errors were minimized? Is the p-value. So we write that p less than 0.05 is considered to be statistically significant. We can also write p less than 0.01 is considered to be highly significant. When I want the error to be less than 1%. That means in 99% of cases, or 99% of repetitions of the experiment, the drug will give the same result. This is very strict. 5 to be theek hai, but 1 is very strict. 99 or beyond it should give the results, which is very, very strict. Okay. And you can also keep 0.001, which is very highly significant. That means in 99.99 cases, the drug should work. And the error is 0.001, which is a very minute error. But to achieve this, you will have to take a very large trial, very huge sample size. It cannot be done on an individual basis. It has to be done on a pharmaceutical level or a institutional level or a company level. Okay, fine. So can anyone answer this? Suppose 4 out of 100 were left to error. So do you think the drug works?
Yes, sir.
So 4 was error. So we have
Yeah.
minimized the error to below 5. Very good. Now the next question on the slide. So 3 out of 100 were in error. The drug works?
Yes.
Yes.
Yes. Now the next answer.
No.
7? No. So here 93 were cured, but 7 were under error. So P became more than 0.05. So we say that there is no difference or the drug fails. Okay. So we'll just see one more example here. So suppose there is, a high court judge who is giving a judgment. उसके सामने एक कैदी को पेश किया जाता है. And based on the facts, proofs, evidence, the person has to be decided either to set free or to give a punishment for a, say, murder. Okay. Now, there is no crime done in reality and the person was set free. So any problem? Anyone has any objection? No problem, no objections. The person did not do anything. No punishment was given. Here in D, the person had committed the crime, had done the crime, and was punished for the same. So anyone has any objection? No problem. So
No.
again, we are seeing that A and D boxes are good. No problem. Okay. Now where the problem lies? In the box B and C. B and C. In reality, or whatever the evidence says, the person has done the crime, but he was set free. So there could be a problem in the judgment. There could also be a problem in the judgment when actually the crime was not done and the person was hanged. So what is more dangerous, B or C?
Actually,
Yes.
B.
What hurts you more?
B.
B. तो किसी innocent को फांसी पे चढ़ाना hurts you more rather than कोई खूनी को एक बार के लिए ठीक है छोड़ दिया, maybe he will, सुधर जाएगा बाद में, whatever. So what is more dangerous? B. So we try to keep this low as possible. This is allowed, little bit allowed, but not so much. So alpha error, because it is more dangerous, we keep 5%. Beta error, little bit allowed, so we keep at 20%. Easy to remember. Now, the other names for alpha error is sampling error or individual factors error or type 1 error or alpha error. Now, what are these individual factors or sampling errors? Suppose out of 100, the drug did not work in 5. Maybe कुछ metabolic illnesses हैं. There is some kidney failure, liver failure. The drug is not getting, binded to some proteins or is getting eliminated, whatever is the condition. So these are all individual factors. So it's also called as sampling error or subjective error. Now, in research, there could be many other errors, more than 1,000 errors can happen in a study. So all those errors collectively, if they fall or make to 20% is allowed. So 20% तक चलेगा, no problem. But this has to be minimized to 5% or less. 20% is also maximum allowed. So it should be also less than 20%. Okay. Now, have you seen a colony counter in microbiology? Anyone? You have a Petri dish and you have a colony counter. It can be manual or digital. You can do this counting by yourself, or you can have a probe which will mark the grids and it will scan it. So what is better, digital or manual? Where will you have more errors? Digital will be computerized. It will take the area only once. But manual अपन कई बार 2 बार repeat कर सकते हैं, 3 बार repeat कर सकते हैं. So that will lead to errors. So what is better?
Digital.
Digital is better. But in contrast to this, the mercury column BP apparatus signomanometer versus a digital BP apparatus. What is better? What is more reliable?
Mercury.
Mercury. Yes. So every time modernization or digitalization may not help. So you have to justify in your study that I am taking so and so instrument, I am taking so and so index, which will give me less of beta errors. So you have to develop a mechanism how will you reduce the beta error in the study. Only then you will be allowed to keep less than 20%. So you can keep beta error to 10%, 5%, 15%, any number below 20, but your methodology should justify how you are going to reduce the beta error. It's not always you are using modern techniques and you are reducing the beta error. Am I clear till now? Any doubts?
No.
Okay, fine. So we are done with alpha and beta errors. Now, a misconception. So I think many of you are staff members also who are attending. So we always keep insisting, p value should be significant. We tell our PGs also, p value अच्छा आना चाहिए, significant आना चाहिए. So is it that the case? Should it be significant always? No, it should not always be significant. Why? Suppose you have developed a new remedy A, a new drug A. A gold standard B, gold standard, is being compared. Now p-value non-significant means no significant difference exists. No difference. That means drug A and B are equal. So you should be more than happy that a new drug which you have developed is as good as a gold standard. So P here should become non-significant. There should be no difference between the effectivenesses of drug A and drug B, ideally. So A can be superior, B can be superior, or both can be equal. So P value always significant is a myth. It's a wrong notion which we have in our minds. Okay, fine. So just see this slide. Just see this example. There are how many groups you can see? 4 groups in the study. There is intergroup and intragroup comparison. So we can study this versus this versus this versus this. This will be called intergroup between the groups. Okay. And if I am seeing vertically, in the group, is there a difference happening from baseline till mid training till post training? So this is called as intra-group comparison. In a single group, there are 3 time points, and I'm comparing the 3 time points. In every group, it's called intra-group comparison. Now, the first statement says at baseline, P is more than 0.05 between the groups. That means group 1, 2, 3, 4. P is more than 0.05. That means no difference. Is it good for the study or bad for the study? Anyone? Is it good or bad?
Bad.
It is actually good for the study because at the baseline, all the groups had no differences between each other. That means you are starting with a common point. You are having a race and everyone is standing at the point zero, line zero. It's a fair race. No one is doing a cheating. No one is standing ahead. Okay. Fine. So mid training, there was no difference again. So what does this indicate? Suppose the training was there mid intervention 6 months. So till 6 months, we could not see a change in any of the groups. Whatever there was, all the groups, या तो सब अच्छे हो गए या सब बुरे हो गए. All are in the same boat. But post training, there is a highly significant difference between the groups. That means after the intervention, post training, some groups are performing very good, some groups are performing very bad. So there is a change, there is a difference between the 4 groups post training. So this is how you read the t values. Now, what is better, not better, that you will have to see the mean, standard deviation, median, or any other value. P will only tell you whether there is a difference or there is no difference. Am I clear? Okay. Now we'll just see the change scenario. Now we are talking of intra-group comparison. So within a single group, for example, control, P is more than 0.05. So in a single group, in the control, when I'm comparing baseline, mid-training and post-training, P is more than 0.05. That means there is no difference at all. No difference means I'm not doing any training. So whatever scores were there at the baseline remained same at T1, remained same at T2, time interval 1 and time interval 2. So from baseline till T1 till T2, there was no difference in the control. There is no change. But P is less than 0.05 in group 1, 2 and 3. That means from baseline till T1 till T2, in all the 3 groups, 1, 2 and 3, there is some difference when I'm talking intra-group or vertically if I'm comparing with time intervals. So this is how you read the intra. Now what is better? Again, you have to see mean. So was the mean initially higher and then it started falling, or the scale is reversed? So initially the mean was less and then it started increasing. That you have to check with the scale. If it is a knowledge scale and the score is increasing, that means it is better, that there will be increase in the knowledge. Okay. Or if it is a disease index, so initially the mean was high and then it started falling, that means the disease is going away. So you have to check with the mean values of the scales or the indices. Okay. Now we'll talk of directly a example. See here on the slide. So intra-group, hypothetically, I'm giving paracetamol plus aceclofenac, diclofenac, and diclofenac plus some corticosteroids. Hypothetically, it's not indicated in everyone, but yes, it has side effects. But now the results will show that only plain paracetamol, only one remedy, basic remedy, in the control group was P more than 0.05. Also in group 1, it was more than 0.05. That means no change happened in the pain, suppose if I talk in group 1 and group 2. So should I waste my patient's money for aceclofenac? No, if it is not giving any extra benefit. But in group 2, P less than 0.05, that means diclofenac works. It is in the pain score. In group 3, P is less than 0.01. Highly significant difference was obtained with this combination. That means initially if the pain was 10, it actually became 0. Highly significant. So this is how you have to weigh. You have to think in terms of the change in the values. So, do we answer this question? P should always be significant? Yes or no? Is it a myth or it's a belief or it's a reality? So, it's a myth. P should always be significant, only then the study is successful? No. P can be non-significant. P can be more than 0.05. At times, it is good for your study. What about negative researches? Suppose I do a drug trial. I tried to invent a new drug, but it is not giving any extra benefit. Should I publish this data? Yes. Will a journal accept this data? Yes. A negative publication also is equally important so that the other researchers do not waste time in future. Or they will learn from my research that what mistakes I have committed. So in future, some other investigator may not commit that mistake and may evolve with a new method or a new mechanism, which I may have failed. Am I clear, everyone?
Yes.
Everyone? Okay, fine. So do you want a short break of 2 minutes or we continue? Don't leave the auditorium. If you want break, you can be just relax for 2 minutes. Tell me, Fatafat, you want a short break of 2 minutes?
Yes, sir.
Okay. So just relax, restore your glucose levels.
करते हा एक्सपिरियन्स वाटतं की माझ्या ह्याच्यात पण असेल ग्रुप पण बनवलेला मी ऑर्गन डोनेशनचा त्याच्यात असेल बहुतेक
एक्सक्यूज मी मिता मॅडम माईक ऑफ करा मिता मॅडम माईक ऑफ करा
Okay, should we start again? All are back?
Yes, sir.
Okay. Yeah, leader, you're there? Yeah, should we start? Please be seated, be quick.
Yes, sir. Yes, sir.
Okay, we'll start. Okay, fine. Okay, so now you can see on the slide. So we have discrete frequencies and continuous data. Okay, so when I'm talking of data as a number, discrete means whole numbers. So if I count the number of males and females in the class, so I'll just be counting. I cannot take an average. Am I clear? I cannot take an average. If I label male as 1 and female as 2 or vice versa and take an average, the average comes to be 1.5. It means nothing. Okay. So when I have numbers, numbers can be counted, or even numbers can be continuous data. So if I have mean height, weight, BMI, blood pressure, so all that can be taken as an average. So we can treat numbers in two different ways. Numbers can also be classified, data can also be classified as per categorical data. That means it has certain quality. So quality of the data would be like male, female, black, white, thin, thick, tall, short. So that all becomes nominal data. Ordinal data means mild, moderate, severe. As the grade increases, rank increases, the severity is increasing. Example, pain scale. So in your pain scale, VAS scale, you can see that from 0 to 10. As the score increases, the severity of the patient's pain increases. Am I clear, everybody?
Yes, sir.
Okay. So nominal, ordinal. So why they are under categorical? Because they are more like a quality. They are more like a category. But in non-categorical, when you have numbers, only numbers to have. So interval scale can be a scale without a true zero. A true zero will not be there. Can I have a person with zero height and zero weight? The person will not exist. So there is nothing called true zero in a interval scale. But in a ratio scale, there will be a true zero. A upon B can become zero. Anything A, anything B. If you divide, it can become zero. Okay. So categorical, non-categorical. Why are we seeing all this? Because your tests will depend on the type of data which you are collecting. Okay, so this is again just to sensitize you. You can go in details of this, you can read many books, but this is just basic. So parametric and non-parametric are the two types of tests which we conduct. Okay, why are we conducting this kind of test? This is to check your hypothesis. This is to generate your p-value, the probability of the experiment crossing 95%, the probability of your results being true. When you repeat the experiment 100 times, does it cross the limit of 95? So that we are checking using certain tests. So what are those tests? They come under two categories: parametric and non-parametric. But if you try to interchange, you will fail. So I cannot do this way. I cannot go this way 100%. We will see situations where we can reverse, but it's better not to reverse. Nominal and ordinal data has to be directly checked with non-parametric. Okay. Now, if I am working with interval and ratio scale and the distribution is normally distributed, you all know what is normal curve? Normal curve, is it
Yes,
covered?
sir.
Yes, it is covered. Fine. So if the data follows a normal curve, go with parametric. If the data does not follow a normal curve, so suppose it is a skewed distribution, skewed to the right or skewed to the left. So if this plateau is more or the right side plateau is more. So in either case, you have to go with non-parametric. Okay. Now, if the sample size is small, you directly go with non-parametric. If the sample size is more, you can go with parametric. But if you are using interval ratio and still the sample size is small, you'll have to again go to non-parametric. So I told there is no clear-cut line of demarcation between parametric and non-parametric. There are certain overlaps, and these overlaps have to be taken care of. But of all these factors, the most important factor is you have to check the normality of your numerical data. If it is normal, go with parametric. If it is not normal, go with non-parametric. So, have you heard of Wilcoxon sign rank test? Have you heard of paired t-test? Everyone, I'm very sure. Everyone must have heard it. Okay. So, paired t-test comes under what? Parametric or non-parametric?
Non-parametric.
Okay. Paired t-test comes under parametric. And Wilcoxon sign rank comes under non-parametric. So, in most of the homeopathy trials, what we have seen till now, what I have seen till now, you will generally have one group of people, say 30 subjects, and we have before and after values of a scale or an index. So I need to compare whether my remedy works. Before, the scale was supposed 10, after the scale became 2. So is there a drastic difference before and after? And generally, what I have seen is most of the students do it by yourselves, go to online resource, put the data and you get a p-value. So most of you apply paired t-test and come up with the result. So there was a difference between the two time intervals, that is pre and post, and we got a highly significant difference. This is what we report generally. So generally, we do not go in for comparison or checking for normality, which is a wrong thing which we are doing, not a very good thing. So we directly apply paired t-test and see the data is whether the data is normally distributed or not. We directly apply the test and give a p-value. Ethically, technically, it is wrong. Okay, I'll teach you how to do that. Okay, now we'll have a quick brush up of the hypothesis. So leader, is your class aware of what is hypothesis?
Yes.
Okay, so it's a statement of supposition. I suppose, I assume that this is better than the other. A is better than B. It's a hypothesis. It's not a textbook rule. It's not a theorem. So today morning I just told you hypothesis. H0 or the statement of negation or null statement will have negativity. There is no difference in the effectiveness of drug A and drug B. So when you are talking of no, it's the statement of negation. But the same statement can become positive. There is a difference between drug A and drug B. Okay. Now, you know what are variables? Everyone knows what is variable. So
Yes.
suppose, yes. So suppose we have one independent variable, also called as a factor, and one dependent variable, also called as a disease. So suppose I say poor immunity causes tuberculosis. So I'm studying only one factor at a time. It's called simple hypothesis. But if I study multiple factors, poor immunity, malnutrition, poor hygienic conditions, stress, use of steroids, all this causes tuberculosis. Means, what does it mean? You are studying a complex hypothesis. Multiple factors is to one outcome, one factor with multiple outcomes, or multiple is to multiple outcomes. All these come under complex hypothesis. Now we'll see directional and non-directional. So directional means I already know that there is going to be an increase or decrease, either way. So I know the direction already. What direction we are talking of? I'll give you a simple example. Do you know how the dental caries happens? दांत सड़ता कैसे है? If we consume more sweets. So if I give a hypothesis, more is the sugar consumption, more is the number of decayed teeth. So I know the direction. It is increasing with the increase. But if I say dental caries may be associated with consumption of sugars. So do I know increase or decrease in this statement? No. I do not know the direction. Okay. Why this is important? Please make a note of this in your book. This will be important when you are doing PG post-graduation. Your statistician would ask you, what is your hypothesis? So based on the hypothesis, we will decide what kind of test are you going to apply. Okay. If your hypothesis is directional, you will go in for one-tailed test. If your hypothesis is non-directional, you will go for two-tailed test. This is little bit, higher level, but for now, just remember this. Again, while doing the p-value ourselves, we generally ignore this type of, comparison. We don't know. We directly apply the p-value, we directly apply pair t-test, whatever, and we do not know ki directional tha, ki non-directional tha, because it is also important. Okay, so we know what is normal curve. We have seen that people should be falling under 95 or more area of acceptance. So if this is 95 or more area of acceptance, this much is 95%. That means they will obey to the normal norms. They will believe in the normal norms. And we have seen that 5% will be under error. So 2.5 and 2.5 on either side, I'm leaving to error to make it to 5%. Now, if the error is there on both sides of the normal curve, it is called two-tailed distribution. Two-tailed distribution, which is used with non-directional hypothesis, because in some there will be an increase, in some there will be a decrease. So the error should be there on both the sides. But if I'm using one-tailed test, the error is there only on one side, because people will show the increase, but these 5% people are not showing the increase. Just it's a concept, statistical concept. Nowadays, software will balance everything. No need to do so much in detail. Now we'll do a hands-on. We'll do a solved example to make you understand what is statistics and how the test will work. Okay, fine. So are you ready? So there are basically 5 steps in statistical testing of a hypothesis. So what are these steps? So first is you will have to make a null hypothesis and a research hypothesis, and then decide whether I want to work with alpha 0.05 or 0.01. So let's keep this as a standard 0.05. Okay. Next, we will decide whether p will be more than or less than 0.05. So this I have told already. So null will say there is no difference. And whenever we obtain p less than 0.05, we say there is a difference. Or when p is more than 0.05, we say no significant difference exists. Now on, use the word difference. We always use the word significance. Significant है result या नहीं है significant. That is not important. Significant difference मिला या difference नहीं मिला, that is more important. Am I clear till now, everyone?
Yes, sir.
Okay. Now, we'll directly go to the solved exam. Okay. Yes. So, this is the exam. So, the research question says, is there a difference in the efficacy? The word is wrong here. It should be effectiveness of metformin versus insulin in the management of pregnancy with diabetes. That means I'm studying blood sugar level, maybe. Yes or no? In diabetes, what is the indicator? Blood sugar, HbA1c, anything could be the indicator. Long-term HbA1c would be the indicator. Okay. But I'm more interested in, say, fasting or random or PP, whatever. Okay. So, is there a difference? Question mark is the research question. See H0, it says there is no difference. And H1 says there is a difference. So I have made the hypothesis. Next step, we will design the study. So in one group, I'll give one remedy, metformin, one drug, and the other I'll give insulin. And it will be a parallel arm study. So both the groups will have the trial going on parallel. Okay. Now I'm giving you values and the formula, just a simple calculation we'll do. This is your baseline 180 value. This is your post intervention value. Post means end of the intervention. 140 and 120 were obtained in group 1 and group 2. There were 30 people in each group. Okay. Now, which test should I apply? It's called the t-test, independent samples t-test. Assuming that everything was okay. We checked for the normality. There was a sufficient sample size. So I'm going to check the hypothesis using t-test. This is the formula I'm giving. So the mean in group 1, mean in group 2 upon, this is called as standard error of the mean. This also I'm giving you. Can you solve this? What's the answer, leader?
4.
4. Now this is the calculated value of, using the formula, I could calculate the t value. So this is the calculated value. And what is the critical value? Critical value is there in the table. Which table? T table. So we'll have to refer to the t table. So everyone remembers log tables hote the school mein? We used to carry those log tables.
Yes.
Yes. So similarly, we have T table, F table, chi-square table, Z table. Many tables are there for statistical calculations. So how does the T table look like? It looks like this. So where do we have to see? Just see. How many subjects were there? 30 in each group. So 60 subjects के आसपास मुझे देखना है. So this is the 60th row. See my pointer on the slide. And in this column, P is 0.05 with two tail. So I'll see in this column, this row, the value written in the table book is 2. What was the value we have obtained?
4.
Very good. So is it greater or lesser than the calculated value? What is bigger? Calculated is bigger or table value is bigger?
Calculated.
Calculated value is bigger. So remember this rule. Remember this rule, which I'm highlighting. If the calculated value is more than the table value, reject null hypothesis. In our statement, what was the null hypothesis? There is no difference in drug A and drug B. No difference. Have we obtained a difference? Yes, we have obtained a difference. And it is significant. Matlab, not only today, if I repeat this experiment multiple times, I'll get the same result. Okay. So every time I repeat this, I get the same result. Significant difference happens. Am I clear? Can we go ahead? So this is how you do statistics. Now, if you are solving for 3 groups, your test will be different, but your calculations will remain almost the same. Your conclusion will be based on this calculated value greater than the critical value, reject null hypothesis. This will always be the gold standard statement. This will always be there with you. So you want to make a note, write this. Calculated value should be more than the table value or the critical value. Reject null hypothesis. Okay, am I clear? Can we go ahead?
Yes, sir.
Okay, fine. So we'll now see what are the types of tests which we want to apply. So the type of test is parametric and non-parametric.
So
Okay.
we have a doubt.
Yes, please ask.
When we are going to choose the type of test that which we should apply to our research.
Exactly. So yes, in the next 5 minutes, this doubt will be cleared. I'm covering those in the next slides. Okay. Yes. So we'll make a situation and which type of test is to be applied in which type of situation is the next part. So the type of test we have is parametric and non-parametric as two major groups, as two major types of tests. Now, the first step, as I told you, you have to check the data's normality, whether the data follows normal curve or does not follow normality. Based on this, we will decide whether to go for parametric or to go for non-parametric. So first step is decision on distribution. So you have to check normally distributed, go with parametric. Not distributed, non-parametric. Okay, fine. These are the 3 golden rules which we have to go in for parametric test. So first rule, the most important rule, it should follow a normal curve. Second, n should be large sample size. And the third rule says it should be numerical. So 1.1, 1.2, 1.3, like that, your numerical continuous data should be there. It should not be a categorical or not a discrete one. 1, 2, 3 are discrete data without a decimal. So such data should not be analyzed using parametric. So
Excuse me, sir.
Yes.
So sample size should be large. Means
Yes.
what will be the count? What will be?
Yes. So I'll come to that point, sir. Very good point. So in general, in most of the studies, I'm not blaming only a particular branch. We generally keep 30. This rule also should be avoided. Generally, we have a tendency to instruct our students 30 ले लो, before after ले लो, single group कर लो, result मिल जाएगा. Nowadays, it has to be determined using a proper formula. So sample size, it's a separate lecture. I think it is done already. So you must have seen various formulae. You should not take arbitrary sample. 30 ले लिया, finish हो गया, नहीं. हो सकता है 30 की जरूरत ना पड़े, 20 में काम हो जाए तो, या 30 sufficient नहीं पड़ेगा, maybe 50 लगेगा. So that is the thing when sample size is large. Generally, all the tests were made earlier with the cutoff of 30. So the previous tables which were made, Z table, Anova table, assuming that 30 will be the minimum sample size. So 30 cross karega, that was the scene. So whenever earlier statisticians used to do this, when sample size was more than 30, go for parametric. But nowadays we don't have such a rule. Sample size should be large and determined by a formula. Formula justification should be there. Many a times we have seen n is equal to 10 per group and still they have gone for one way Anova, which is a parametric, and it suits the data, no problem. So ऐसा नहीं है कि हमेशा large या हमेशा small होना चाहिए. So I told the most important thing is normal distribution, the most important. बाकी सब secondary है. It should follow a normal curve. Only then you go in for parametric. The most important thing is normal curve. Am I clear, sir? So we should avoid now the arbitrary rule of 30. Get a sample size estimation done from a professional, from a statistician, before you start the study. That is most important. Not after the study is done and then we realize they are 30 कम पड़ रहा है या ज़्यादा हो गया, whatever it is. Okay. Clear? All doubts?
Yes, sir.
Thank you. So please remember these three rules. Remember this. Okay. So it should be large, normal distributed, and numerical, decimal or continuous data. Okay. Next one. So how do we check for the normality? Using a histogram. Have you seen a histogram? Everyone? Have you seen a histogram?
Yes.
Okay. So it is somewhat like this. A histogram would be somewhat like this. And if I remove the boxes, it will assume like a normal curve. Okay. Fine. Okay. So this is like a histogram. So these are the bars and the midpoints of the bars are connected, making a curve. It's not a very perfect histogram here. In SPSS software, if you are aware, that's a software. So this line is there. So the point should fall on the line. It should not be beyond the line or crossing outside the line. So if majority points are on the line, we say that it is normally distributed. This is called as a QQ plot. In SPSS, we have QQ and RR plots. So this also is an indicator. The most important thing is Shapiro-Wilk test. Shapiro-Wilk test is the most important test here. Many of your statisticians would do Kolmogorov-Smirnov, but if you read the literature in statistics, if your sample size is more than 2000 per group, you can go in with Kolmogorov. Shapiro-Wilk works with less than 2000 per group, which is most of us studies will be using less sample size. These two are also available in SPSS, not very common. So conclusion is most important is Shapiro-Wilk test. बाकी सब दुनिया गई तेल लेने. This should be the test which we have to check. बाकी सब techniques fail हो जाएंगी. Only Shapiro-Wilk should be believed. Histogram will say something, stem and leaf plot will say something, QQ plot may say something, box and plot may say something, but Shapiro-Wilk, whatever it says, has to be. It is so powerful test. Kolmogorov also fails, but Shapiro-Wilk will never fail. It's a very powerful, very robust test. Okay, now we'll start designing the tests and the situations. So in your notebooks, you can make 3 columns as it is shown in the slide. So we'll write conditions, parametric tests and non-parametric tests. Have you started making?
Yes, sir.
Now this will be a one-page view. Lifelong you can refer to this page. Which test to apply in which situation. Okay, can we go ahead?
Yes, sir.
Okay. So this is what we are giving as many conditions, many situations. So read nicely. One group before, after. So I have 40 people, 50 people, and I'm observing before versus after. So tell me, which test we have just discussed now? Which is the test?
T-test.
So paired t-test. So write paired t-test here. Okay, fine. Now, two groups. It's t-test. Now the other names for t-test is student t-test, independent samples t-test, unpaired t-test. All mean the same. It's called t-test. Fine. Now, one group before, after, after. So suppose I have, few patients or say 50 patients and I want to follow them for baseline. Then I call them at 1 month, 2 month, 3 month, 6 month, 12 month. So multiple follows are done in the same number of people. So how to remember? I am repeating the measurements on the same number of people. So the name says repeated measures Anova. Am I clear? T will work till 2. So two groups or two observations before, after. So T works till 2. T2. After 2, T should not work. It fails. Okay. So have you written this? This is paired T test. Okay. Now point number 3. Two or more groups. It's one way ANOVA. So wherever you use the term ANOVA means it is more than 2. Otherwise it was T test. So T test is still 2. After 2 is ANOVA. Now we have certain substitutes of these tests for non-parametric in this area. Okay, fine. So the substitute for paired t-test is Wilcoxon signed rank test, WSR, short form. The substitute for t-test is Mann-Whitney U-test. Point number 2, we had written repeated measures ANOVA. Here we have to write Friedman's test. And point number 3, where we had written one-way ANOVA, we will have to write Kruskal-Wallis ANOVA. So these are all names. Scientists के names के ऊपर बने हैं सब tests. Just remember, very important. All of these 4 are very frequently used. Wilcoxon signed rank test, Friedman's test, Kruskal-Wallis ANOVA, Mann-Whitney. Now, point number 5. This is chi-square. This is chi-square. So both are chi-square tests in point number 5. So association between any two variables, or I am comparing the frequencies, it is chi-square test. Now the next one, a 2 by 2 table. So 2 rows and 2 columns, like we had seen just now with the example of association. Again, we can go in for chi-square, or to be more specific, a 2 by 2 will have Fisher's exact test. You can write a note. Spellings, you can just go to the textbook or Google, you can check. Fisher's exact test. Odds ratios, relative risk also is calculated in a 2 by 2 table. Okay. 4 by 5 table means any number of rows and any number of columns. Again, you can go in for chi-square. Frequency is less than 5 for a 2 by 2 table. You can go in for Yates correction or continuity correction, जिसको सॉफ्टवेयर में बोलते हैं SPSS में, or you can go in for Fisher's exact. Now the next one is 2 by 2 before after. Here I would like to give an example. Only then you will understand this test. So we have a 2 by 2. Okay. Now this is before, this is after. So positive, negative, or you can say the factor or the habit positive or negative. So suppose this is a tobacco intervention. A group of people, we are giving a tobacco counseling to them. Okay. So many of them were consuming, having the habit, say smoking, were smokers before. After also they continued to smoke. So again we have box A. They did not smoke initially and now also they do not smoke. Fine, no problem. What is the problem? Again B and C is a problem. हमेशा ये B and C सता रहा है. Okay. So what is the problem? B and C. So in B, initially people were smokers and now they have stopped smoking. So this is in fact good for the study. Your intervention will work. But what is bad for the study? This C. They were not smokers first initially, but because of your therapy, you showed them so many products and they started trying. होता है ऐसा कभी कभी, प्रोडक्ट के बारे में मालूम पड़ा और you have to try. So they started the habit after your counseling, which is actually wrong. Okay, fine. So the null hypothesis of this situation will say that there is practically 0B and 0C. It should not be happening. Whoever was there initially, they have no habit or with habit. So null says there is no difference in the conversions, no difference in the before after scores or the situations. But if you see some people in B and some people in C, that means you have to reject the null hypothesis of this test 2 by 2 before after, called as Mech-Niemeyer test. So this is a new test which I am introducing to you all. So this is called as Mech-Niemeyer test. Now the same thing can be done repeatedly, before, after. So every month you recall them and ask for the smoking behavior. This becomes Cochrane's Q. It's also a test. Okay, so who can give me a quick recap of all this? Fatafat. What do we write here, here, and the 4 names here, and the names 1, 2, 3, 4, 5. Chalo, fatafat. Or do you want to write in fair? Write in fair, write on a fresh page. Fatafat.
डायरेक्टली बोलो, माइक है यहाँ पे.
Yes, anyone would like to speak? You can tell.
तेरा इको हो रहा है. दृष्टि. हाँ, yes. हाँ, केला में.
One group before and after paired t-test.
Very good.
Parametric, we can go for WSR test.
Very good.
One group with before, after, and after test. Then we can go for repeated measures Anova test.
Very good.
And for non-parametric, we can go for Friedman's test.
Great. Good. I'm happy that I have been able to be successfully introducing you all the tests. Thank you. Yes.
Next, for 2 groups, we can do t-test.
Next, Gia, stand up, Gia. Next.
MW.
Man Whitney, you. Very good. Okay.
And
Third
then
point.
2 or more groups, one way Anova test.
Very good. And the substitute?
KW Anova test.
Very good. Kruskal Wallis Anova. Very good. Great. Madam, I'm lucky to have your students.
Thank you.
Okay. Next. So we are done with these 4 points. Great. Point number 5, association chi-square in both chi-square, chi-square. Okay. 2 by 2 table.
Fisher's exact.
Very good. And basic chi-square and odds ratios and relative risks. Very good. Next. N by Y table, X by Y table, N by M table, any number of rows and columns. Again chi-square. Very good. 2 by 2 less than 5.
So we have a doubt about that.
So this is called Yates correction. I'll show the formula why we have to do the correction. Fine. Okay. Then next one,
Next is
McNemar. Very good. Uska next.
and उसके बाद है Cochrane's Q test.
Very good. Excellent. Excellent. Okay. So till this much, I'll show the slides. So just see the figures, you'll understand everything. So this is one group before after paired t-test or Wilcoxon. This is two group. So t-test or Mann-Whitney. Very good. Now intergroup comparison also we can do. Intergroup comparison of differences. Okay. So suppose two people are having a race and the one person is standing ahead already. He is standing say here 10 meters ahead. So who will win? जो आगे खड़ा है वही भागेगा जल्दी. That person will win. So at baseline, if there is a difference in the scores, so the group which is already having better value will give better result. So we have to do a intergroup comparison of differences. That is also one of the functions of t-test. So I'll show you what is intergroup comparison of differences. Initially, the value was 100 in group 1 and value of 120 in group 2. After the intervention, the value became here 80, but here the value became 60. So which group is better?
The second one.
Yes. There was a difference at baseline. P was less than 0.05. There was a statistically significant difference at baseline, which should not happen ideally, but it happened after randomization. Also, the groups are not matched. They are not similar to each other. So 100 से 80, यहाँ से 20 यूनिट्स का शिफ्ट हुआ, बट यहाँ पे 60 यूनिट्स का शिफ्ट हुआ. So जहाँ पे ज्यादा मेजर शिफ्ट हुआ, that means the intervention is working more. Am I clear? So you are seeing basically subtraction, and then you are doing the intergroup comparison using t-test. So this is called as t-test for the differences in before and after. Okay. Next, this is the diagram for 3 groups. That means ANOVA, one-way ANOVA. So group 1, group 2, group 3. All the 3 things are going parallelly and the outcome could be same. If you are measuring one outcome, say blood pressure, VAS scale, whatever, it's one outcome. Okay. This is repeated measures ANOVA. So before, after, and multiple follow-ups. Or Friedman's test, either case. Fine. So we'll just now go to higher tests. Now there are post-hoc tests to be done after ANOVA. So after ANOVA, I would like to know whether there is a difference between the 3 groups or not. So for example, just see my drawing. So A, B, and C, all 3 will be compared using one-way ANOVA. One-way ANOVA. But after one-way ANOVA, I would like to see, is there a difference between A versus B, A versus C, or B versus C? This is called as post-hoc test. The beauty of post-hoc test is it will keep alpha value as 5%. If I do repeatedly t-test multiple times, what will happen? Alpha will keep on increasing 5 times every time. But post-hoc will keep the alpha to minimum 5%. It will not disturb the alpha value. There are various names of certain tests. You may come across certain articles, Bonoferini, Tuckey's, Skeffy's, Dunnett's, James Howell, Cochrane's, many tests are there. Okay. Yes. So how to decide? It's a higher level. Your statistician will decide which test to use. Now we'll see certain variations of the chi-square test. So you have this doubt of Yates correction. I'll clarify this. Yes. So what is this 2 by 2, 3 by 3? क्या बोलेंगे इस टेबल को? How many rows and how many columns are there?
Speak.
4 by 3.
3 by 2. So you see 2 columns. Basically, we don't see the headings. सिर्फ अंदर का डेटा देखना है इतना. So how many is this? 3 by 2. Okay. So 1 and 2 columns and 1, 2 and 3 rows. So it's a 3 by 2. Okay. Fine. How much is this?
3 by 3.
3 by 2. Very good. 3 by 2. So do you see that the frequencies of the cells is less than 5? So not even 5 people are fitting into one cell. In such a scene, chi-square will fail. Chi-square test will give you a p-value. It will also give you a chi-square value, but it will not be suitable. It will fail. So in such a situation, wherever your cells have frequencies less than 5, you will go in for Yates correction in the formula for chi-square. This the software does automatically. It's called, in SPSS, it is called contingency correction. In EpiInfo, it's another software. It will tell you, it will give you a warning and it will do the correction by itself. Okay. So the frequencies of the cells should be more than 5 whenever we are going for chi-square test. Otherwise, it will fail. Am I clear? So the formula for chi-square is, I'll show the formula. This is the formula. But the Yates correction would be, you'll have to still subtract 0.5 inside the bracket. No need to manually learn all this. It's all software now. Okay. Now, we'll do certain hands-on again. We'll do certain corrections, calculations. So tell me, do you know the principle of odds ratio? It is done after case control study. So I'm giving you this data and the formula. Can you calculate for me, fatafat, what is the odds ratio in this situation?
Fast.
What is the odds ratio? Formula bhi diya hai, value bhi diya hai. Fatafat batao. What is the answer?
Stand up and tell. 32.4, sir.
The answer, see, the formula says AD by BC. So 33 into 27 divided by 55 into 2.
8.1.
Very good. 8.1. Who is that genius? See, in my school maths class, I never used to match the answers with everyone in the class. And the irony of the life is, today I'm a statistician. Okay, fine. Jokes apart. So the answer is 8.1. Okay. Now in your notebooks, just mention odds ratio more than 1. Am I correct? In this situation, we have got odds ratio more than 1. Barabar? Yes or no? Okay. Now I'll give you one more situation. Can you calculate this?
So 0.12.
Very good. 0.123. Okay. So besides this, you will write odds ratio less than 1. Am I correct? This is less than 1. Okay.
Yes,
Now
sir.
I'll give you one more situation. This one. What is the answer? Simple.
One.
Odds ratio equal to 1. So write in your notebook equal to 1. Equal to 1. Now, we'll go back to the first scene where odds ratio was 8.1. Is this factor a disease causing factor, a harmful factor, or a disease protective factor? Is it a disease causing factor or a disease protective factor? Causation. Yes, it is a causing factor. So write in your notebook whenever you have odds ratio or relative risk more than 1, that means it is a harmful factor or a disease causing factor. Now, the next example 0.123. Is this a causing factor or a protective factor? This is a protecting factor, preventive factor. Why? Those who had this factor, see now, those who had this factor, say vaccine, those who were exposed to vaccine, there were very few people who had the disease. And those who were exposed to the vaccine, given vaccine, many people were there without the disease. So it's a protective factor. It's a beneficial factor. Am I clear? Yes. In the previous case, those who had the habit had the disease more. So it is the disease developing or disease causing factor. Factor positive, disease positive. Am I clear? Can we go ahead?
Yes, sir.
And when odds ratio is equal to 1, this is called null. No association at all. So what is the null hypothesis here? The exposure to X will not cause the outcome as Y. And we are proving this null hypothesis. Whether X hai ya nahi hai, Y ho raha hai, nahi ho raha hai, it is immaterial. There are equal numbers of 50, 50, 50, 50 in every box. So it is the line of null, no effect. Am I clear? Can we go ahead? Okay. Now non-parametric tests have limited rules. The 3 golden rules which we saw for parametric, such rules do not exist for non-parametric, but they lack the power. So power lack means they will show a p-value which is significant always. Many times you will get a significant p-value with non-parametric, but they lack power. It's not very a powerful test. Okay, fine. Yates correction, I told you inside the bracket you have to subtract minus 5.5. This is when your cell frequency is less than 5 in any box, in any cell. Fisher's exact test, just go through these slides. So what we had done, 2 by 2 table, go for Fisher's exact test. McNemar is before, after, but your data is yes, no, yes, no. And multiple follow-ups done before, after, like repeated, but your data is a 2 by 2 table. Yes, no, that becomes Cochrane's. Okay. Now we'll go one more step ahead. Regression and correlation. So correlation means, today morning I told you, it's like plotting a straight line. Now in this case, the straight line will go through all the points. So every unit change in X, as X increases, Y also increases. So this is called as a positive and a strong correlation. Your correlation graphs may also come to be curve and a linear line, so curvy linear, or they can also be a part linear. So only a part is linearity, rest it's not linear. Okay. But most of the situations we generally go in for a straight line in our data. Positive correlation means as X increases, Y increases. Negative means as X increases, Y reduces. Now, how do we rate the correlation. So the correlation is rated on R value. Pearson's correlation R value. This you will read in the articles, you will come to know. So R value means the strength of association or correlation. Nearing to 1 will be very strong. So R can range from minus 1.0 through 0 to plus 1. So nearing to 1, it's strong on either side. Nearing to 0 will be again null, nothing. So 0 means nothing. So if I say positive 0.4 and negative 0.9, what is stronger?
Positive.
Positive 0.4 is stronger, but I told it should be coming near to 1. It should be coming near to 1. So 0.9 is near to 1. Although negative, the magnitude or the power is near to 1. Negative sign will only show that as x increases, y will reduce. Inverse correlation. So ignore the negative sign for now. And now tell me what is better, 0.4 or 0.9? 0.9. So nearing to 1 on either direction is better. It will show up positive or negative, whatever, but a strong relationship. So this is a strong relationship when every unit change in x causes the unit change in y. This is somewhat moderate. So few points will lie outside the line. So if I make a straight line, not all points will pass through the straight line. Few points are lying outside. They will show the deviations. So we are telling it's not a perfect positive. It is somewhat moderate. Okay. There is no correlation in this. 0, null line. R is equal to 0. So no relation can be made out of IQ and height. As height increases, IQ increases, or as IQ increases, height increases, no relation at all. We are studying two wrong factors. Negative correlation, it's again moderate, not a perfect one. So a straight line will pass through points, but the many points will lie outside. So it's not very perfect positive. But the perfect positive line will be like this. All points will lie on the same line. Okay. So here R will assume -1. But again, negativity is only showing the relationship as x increases, y increases, y reduces. But the magnitude of 1 is very good. 100% there is a correlation. Am I clear till now? Done? Are we clear?
Yes,
Okay.
sir.
Okay. Fine. So this is the conclusion of R. So R should be near to 1, as I told you. So it indicates high correlation. Near to 0 means it is indicating slight correlation. Okay. Now, we have Pearson, we have Spearman, we have Kendall's tau as 3 measurements of correlations. Now regression, as I told you the equation in the morning, y is equal to ax plus b. So if you are studying only one factor, it is simple regression, or multiple factors, you are seeing multiple regression. Linearity means straight line. Logistic means it has log models, it has percentage models, it has probability models. Many further models are there. So this is the generic equation, y is equal to a plus bx, where a is a constant and b is called the coefficient of the independent x. So if I know the value of x, I can predict the value of y with the equation. Where it is used, as I told you, in forensics, in labeling the body of the dead, in identifications, what was the age, what was the gender in a mutilated body, badly decayed body, badly destroyed body, or even in live humans, we can have age estimation by various skull-based measurements, by various dental measurements, by various foramina, closure, opening, positions, all these things we can have the age and gender determined. Survival analysis, as I told you, it is done in cancer studies. In many dental studies also, how much is your filling going to take? सिल्वर भरते हैं, चांदी भरते हैं, दांत के रंग का मटेरियल भरते हैं, composite. So 5 साल चलेगा, 10 साल चलेगा. So all that statistics we do. So it is called as Kaplan-Meier survival plot or Cox proportional hazards or a log rank test. ये अलग अलग टेस्ट होते हैं for survival. Okay. Now we'll go to Cohen's kappa. So what is Cohen's kappa? Suppose there are two examiners. I am seeing someone for a behavior. So I will label the person to be having a normal behavior or a suspicious behavior. So this is done by observer 1. Observer 2 also will label the person to have normal or suspicious behavior. Now, when are the two observers in agreement? Again, वही same A, B, C, D, same thing. So A and D are in agreement. इसने भी normal बोला, इसने भी normal बोला, इसने suspicious बोला, इसने suspicious बोला. Where the problem lies is again B and C, where they are not in agreement. One says normal, other says suspicious. One says suspicious, other says normal. This is the problem. Okay. So what is the degree of agreement between the two examiners is done by kappa statistics. Am I clear? Remember this. You will be utilizing this somewhere or the other. Okay. Fine. So this is what I was talking of. 2 by 2 table with a suspicious and normal behavior rated by 2 officers, 2 observers, but the same number of people. Again, we have this value, say 0.593 here in this example. Again, we have a conclusion nearing to 1 is near perfect. Otherwise, nearing to 0 is poor. Okay, can we go ahead? Now we also have intra-class correlation. So when there are numerical agreements, measurements done, and you have to see the agreement. So one person says it is 1.1, other says it is 1.12, other says it is 3. So you have to rate them as per the numerical agreement. Again, more than 0.8 will be almost perfect. Okay. When we make a questionnaire, we generally go in for Cronbach's alpha. It's an internal, as an indicator for internal consistency, reliability, how well the questions are made. Okay. So just remember Cronbach's alpha. Again, nearing to 1 is excellent. Nearing to 0 is not excellent. So you can take a photo of this slide. You can take a screenshot of this slide. This is the 1-page view of all the tests which we have discussed today. Any doubt? All things are clear. Have we discussed all this? Anything which you have not been familiar with? Anything you are in doubt till now? Ask me right away. Just one more, correction rather than you can say suggestion. This could be n by m table. It's just any number of rows and columns. Here you can add odds ratio, relative risk also. Now you take a photo. And this was the earlier name given. This you can cut off. It's chi-square or both.
Hello, sir.
Yes, madam.
Prapti is asking.
Sir, my question is that where we can use Fleece kappa statistics in our research?
Yes. So Fleece kappa is when you are having an ordinal data. It's in ordinal ranked data and more than 1 or 2 examiners or observers. Fleece kappa, very good question. Have you come across this? Not many softwares handle Fleece kappa. And not many statisticians are also aware about Fleece kappa. It's a very latest test. Very good question. So when you are doing an ordinal ranking, an ordinal scale, 0, 1, 2, 3 gradations, very likely, positive, somewhat likely, somewhat not likely. If that is the scale and you are rating individuals on that scale and more than 2 observers. So it's not a dichotomous scale of yes, no, like we have in kappa. It's an ordinal scale in kappa called Fleece kappa. Very good. Very good. You have come across this? Great. Okay, any other doubts? Any other doubt? Okay. Fine. So can we go ahead? Should I remove this slide?
Yes, sir.
You have taken a photo or something? Okay. Yeah. So this is one good article I had just come across, a very basic article. It has given all the tests. You can just go through it. Okay. Now there are certain terms called ITT, intention to treat, and per protocol. Again, this is advanced, high level. So I'll just explain you in one line, one short line. So suppose, I'm doing a drug trial of drug A, which is a new one, and drug B, which is a gold standard. Now, during the course of the therapy, many patients in drug A started developing some side effects, or they did not start responding, or there were a lot of deaths happening. So I had to shift people, few people, say 5 people, from A to B because of the worsening of the symptoms. Now, should I include this data of 5 people in A or B? My intention was to treat them as per the drug A. So it is called intention to treat analysis. My intention was good. So the data here belongs to A. But what I actually followed, they were shifted to B. So the per protocol, as per the protocol, their data should go in B. So this is per protocol analysis. This is mostly done in cancer studies or termination studies, wherever death would be an outcome. So this is the future. People have started reporting this also. Okay, fine. Now, leader, can you read this for everyone?
Significance in real life situation. Example, length of hospital stay after open OA and laparoscopic appendectomy. LA is 3.16 days, OA is 3.20 days. Difference is 0.04 days is equal to 1 hour. Clinically irrelevant difference.
So what we mean to say is, we will advocate कि laparoscopic करवाओ, बहुत highly significant difference in the hospital stay. जब आप actually data देखोगे तो it is just 1 hour. Does it make a difference to the patient? 1 hour of hospital stay hardly matters. So we project statistics in a very polished way, in a very different way. Okay, next example. Diabetes reduced from 400 to 315. Highly significant difference was reported in the article. Is it beneficial for the patient? Is 315 normal? No. अभी भी उतना ही रिस्क है. Okay. Next example. So massage increases 47 seconds per night sleep. Is it relevant? 47 seconds क्या होता है? Okay. So this is where you have to apply logic. Statistics ही सब कुछ है नहीं. You have to apply logic. You have to apply your brains. Okay. Fine. Volunteer, leader, please read this for everyone.
Interpretation of observations. There once was a scientist who studied frog. One day the scientist put the frog on the ground and told it to jump. The frog jumped out 4 feet. So the scientist wrote in his notebook, frog with 4 feet jumps 4 feet. So the scientist cut off one of the 4 legs. The scientist told the frog to jump. Frog jumped 3 feet. So the scientist wrote in his notebook, frog with 3 feet jumped 3 feet.
Next.
Scientist cut off another leg. He told the frog to jump. The frog jumped 2 feet. So the scientist wrote in his notebook, frog with 2 feet jumped 2 feet. The scientist cut off one more leg. He told the frog to jump. Frog jumped 1 foot. So the scientist wrote in his notebook, frog with 1 foot jumped 1 foot. So the scientist cut off his last leg and asked the frog to jump.
So what is the conclusion?
The frog cannot jump.
Yes. So what the scientist has written in the book finally?
The frog cannot jump.
Because of the reason of dash. Why he did not jump?
No legs, he cannot jump. No foot.
Okay. So every time the frog is being asked to jump, the frog tries to jump. जितना भी कूद पाया उतना. But last leg काटने के बाद भी हमने बोला कि jump. The frog did not jump, could not jump. Why? So the scientist wrote that the frog becomes deaf when all the legs are cut because he is not obeying to my instructions. So this is where we fail in logic and we only think about statistics. Okay, see this. So this is the conclusion. Is it correct? Logical? Not logical. So without logic, it's only mathematics. But mathematics plus logic becomes biostatistics. So please don't go away with your logic. Don't be, lost in figures, numbers. Am I clear? Yes. So any questions in this lecture? It was a long lecture. We covered many concepts. Any doubts? Yes, ask.
Explain ITT versus PP once again.
Okay. So see, intention to treat is ITT and per protocol is how the protocol went, how actually we worked out. So suppose there were 50 people here in a new drug A new. Okay, in B gold standard, there were 50 people. Out of these 50, say 10 developed symptoms or worsening of the symptoms or did not respond. So I had to shift them to the gold standard. Now this data of 10 should belong to A or because it was shifted should belong to B is the question. So we do statistical analysis based on this. If the data was belonging to A, it is called as my intention was to treat them under A. So the data belongs to A. But what actually went on in the protocol, what actually was followed per protocol as per protocol is they were shifted to B. So now the data should go to B. This is the difference. It has advanced statistics inside. This is just a concept. I'm just sensitizing you कि ऐसा कुछ होता है. This will be there in comparative studies, even in homeopathy. When you are trying a remedy versus a gold standard, you may have to shift people who do not respond or who have to withdraw, who do not follow up. So, you have to change them to the gold standard drug. So, but it requires high level of statistics. So your sample size has to be huge to balance. Should not be done in small trials. Okay, fine. Any other doubt? So I would encourage you all to read more on Bergsonian bias. You may be familiar, have-thrown effect, and novelty effect. Okay, read more on this. If any doubt, we can catch up later. No problem. You should also be familiar with dilution effects, diffusion effects. Just read more. It's again a concept. Before you begin any human trial or you are a part of any human study, I would encourage you all to undergo a GCP training, good clinical practice. If the college can organize a workshop on this, it will be very good for all your students. We have this GCP certifications. It's very necessary for PGs. It is also essential for UGs.
Yes, sir.
Okay. Yes. Yeah. So any doubts? These are my contact details. We are not done yet. We have one more session on computer assistance. I'll show the demo of software, how these tests will work in SPSS, Epinfo, online resources. Okay. So any doubts? Can we go ahead?
Yes.
Leader? Okay, fine. So I'll just stop sharing my screen for a while till I'm ready with the softwares. Okay, are you able to see the slide? Is it moving?
Yes, sir.
Okay. So see this is what we have covered just now. All this has been covered just now. Can you appreciate what is this? Cockpit, okay, of a aeroplane. Which make? Company? You don't know. Okay, fine. This, which make or company? You know or don't know? Is it different from the previous one? Are the models different? Makes are different? Yes, volunteer? Leader?
Yes, one is
Yes, sir.
Yes. Which one looks more complex? The second one? More complex, more computerized, more automated. And the first one looks more manual. So these are your softwares. Someone will have extra buttons, extra analysis windows. So SPSS, Epinfo, MedCalc, GraphPad, Epinfo, Excel sheet. So these are various resources which we use. Okay. Now, this is the cockpit of a racing car. Can it fly? Can a racing car fly? Like a
No.
plane? No. What is the investment? Is it as heavy as a plane? No. And what is this? A simple normal Wagoner, Maruti. So can it even race? After 120, it will start shaking, it will start vibrating. So heavy the investment, more features will get. Okay. So now we'll see what are these various kinds of softwares we are talking of and how to do data entry on the Excel sheet. Okay, fine. Now we all are actually scared of operating on an Excel sheet, but it's very simple. So how does the Excel sheet look like? So how to open? From a right click on the desktop, you can go to new and you can open a new Excel sheet. This is the old version of Excel sheet. This is the new version, how it looks like. So basically, this is a row This is a column, and every box is called cell. You have certain headings on the top: home, insert, page layout. This is like a word format. So where you want to set a page for printing, A4 size, or you want to color the text or the color the background, or make a box, bold, italics, underlines, all these things will be available. So these are very basic functions in the Excel sheet. More importantly, you can have graphs and plots made on the Excel sheet. So you can make a column, you can make a pie chart, a scatter plot, a line diagram. All these are the features available for charts options. You can have formulas in the Excel sheet, a basic formula of addition, subtraction, division as basic formulae. But yes, it can also do t-test, Anova, but it will not generate that kind of good tables as a software would do. So you'll have to remake the tables for the article or for the publication or for the thesis. In Formula, you can download an extra package under more functions from the proper Microsoft Office website. So they will give you regressions, correlations as extra functions in the package. It is free of cost. Okay. Now how to control C, control X, control V are the normal keyboard shortcuts we use for cut, copy, paste. We can also merge and center. We can draw a color. We can edit the fonts, font shape, font size, the type of the border. So all these is possible. So this is basics. Now how to do data entry for various study designs. So suppose I'm doing a survey. I want to do a survey. I want to use a questionnaire for a survey. So the questionnaire would be suppose having like this. So part A of the questionnaire collects the class, gender. So such kind of demographic variables are collected. Now the next part onwards will be your responses to the questions. A, B, A, B, C, D. So all these are the responses everyone would tick. Now how to do the data entry? This was pre-COVID when we used to circulate the forms physically. Nowadays you can have a Google or a Survey Monkey where it will generate the data in the Excel sheet itself. So no need to make the Excel sheet. But yes, if you are still again going for a physical form, your Excel sheet has to be coded. So I cannot write male MALE. I will write 1 and female code 2. So this is called coding. Why we are doing coding? For the software to understand. We want to try to make it as numerical as possible. If your statistician uses Spss software as the favorite one, it's better to give the data in numerical format. If you are using Epinfo or some other software, then words also will be okay. So once you have coded for all the questions, your Excel sheet would look like this. So the headings should be there only in one row. See, the headings are there only in one row. Do not utilize multiple rows for only headings. And the entire data sheet is coded in numerical way. 1, 2, 3, 4. Nowhere you can see ABC. So letters are not there, only numbers will be there. This is one more example of, now here I have entered the keywords in the title, in the headings, so that when the results come, it will directly come with the numbers. Next, I want to measure some dental problems, some index, some disease index with the age and gender. So the golden rule says, write your independent variables on the left and the dependent or the outcome variables on the right. Please write this in your book. This is a golden rule. The independent variables or the factors on the left side and the outcome variables on the right side. These are the outcome variables on the right side. Why this is done? So that we can demarcate the effect of gender on plaque index, effect of age on plaque index, brushing on plaque index, original index. So we are demarcating what comparisons we are about to do. This will be helpful for your statistician to understand the data. Okay. Here also I have done the same thing. So on the left is age, gender, and on the right is the total anxiety score, is the outcome. Now, case control study. So your Excel sheet should look like this. So what defines whether the person is a case or a control is this column. So maybe this is a case and this is a control. So we have coded as 1 and 0. Am I clear? In a cohort, the most important column will be the presence or absence of the habit. So if this is habit positive, yes. This is habit negative, no. This defines this person is a cohort and this is a control. Okay. Next, clinical trials or clinical studies. So there are suppose two groups and two followers. So your group should be one below the other. Remember, again, write this in your books. Groups should be one below the other. So 1, 2, 1, 2, as and when you finish the case, you can keep on entering, or you can make two separate Excel sheets for group 1 and group 2. That also is allowed. Your statistician would merge them, group 1 versus group 2, compare करने. All the time intervals should be on the right side. So time intervals, baseline in B column, then 1 hour follow in C column. So likewise, you have to keep entering one besides the other for the time intervals. Am I clear? One below the other for groups, one besides the other for time intervals. So to compile both the sheets, this is how your data should look like. Groups one below the other and time follow up one after the other on the right. So suppose I want to add 2 hours also, I'll add here 2 hours. I want to add one more group. So group 3, I will add below here, group 3 data. Am I clear, everyone? Leaders?
Yes.
Okay.
Yes.
Okay. Now these are certain common mistakes which we do on the Excel sheet. So can you identify certain mistakes? Yes. Any mistakes? A, B, C, D we have written. It should be 1, 2, 3, 4. We have utilized 2 rows, which is wrong. If I want to code dental medical, you can write 1, 2, 1, 1. You can code this medical as 2 and utilize only one row, one column for the entire data. While entering, you are writing years and wasting time. So write age in years in the heading and just write 23, 45, 42. When you are writing, you are actually not writing in the gender column. If you drag this, this is blank. This column is blank. And you did not realize while writing. Okay, fine. So these are the common mistakes. This is a blunder. This should not be encouraged. So you are actually having one simple numerical data. If you are asked to code it, you should not code in this way. Just code. Just remove mm and write the data vertically. That's it. इतना complex है ही नहीं इसके अंदर. Again, certain common mistakes. When we give Excel sheet to our statistician, we can hide various columns. So A से D आ रहा है, E के बाद G आ रहा है. But the software will recognize the hidden columns. So it will also analyze the data which is not required. That will add up to the cost. There are certain spelling mistakes. There are certain writing mistakes. If you're writing in capital and small, it will be taken as different in the software. So curved small kitne likhe the, it will count that. Curved big mein kitne likhe the, it will count that, but it means the same thing. Okay. Now in this Excel sheet, you are seeing almost 22 rows, but the data belongs to only 4 patients. So your result will be not very properly made. Whatever you are using, as in more than one row for every patient, you can enter this data to the right side. So if you are having 4 patients, you will have only 4 rows in the Excel sheet, ideally. You are writing as a waste of time. So you can write here in the heading itself. Am I clear? Yes. Do not merge 2 types of cells. You can write here length right and length left, shape right and shape left. so that your row also is spared. One row also is not wasted. Okay. While entering data, there could be certain button hits on the keyboard, which makes the age unrealistic. So we fight with our statistician, sir. The age of my patient, mean age has come to 250 years. 250 साल कौन जिंदा रहता है? Then your statistician will show, बच्चा आपका case number 4 and case number 12, so 333 years and 233 years जिंदा रहते हैं. So this has to be taken seriously. Okay, fine. Next is the functions, which I'll give you a demo. Okay. Now you can also have more functions and t-test, but again I told you it will just give you the p-value 0.000005 whatever, without actually generating the t-table. It can also give you the f-table, Anova table, but not a very realistic f-table. So better that we use certain paid softwares or a free Epinfo as a software, which I'll give you the demo right away. So Epinfo is a software given by CDC Atlanta. It's free of cost. You can download and keep it for your PC. Later on also you can download, no need to hurry. If the laptop gets spoiled, I lose my software. It's always available free of cost on the internet. So you can install it, or you can use the online resource or the online version also. I'll show the screenshots of this. So this is the stat calc for sample size estimations. This is the classical window for data analysis. Now, when I work with Epinfo in data analysis window, it will show like this. Now you have to upload your Excel sheet inside the Epinfo window. So you can go to here, read. It will open a new location. It will start browsing your Excel sheet. Are you able to see the screen properly? People who are sitting at the back. Is it clear on the slide?
Yes, sir.
Okay, okay, fine. So it will start browsing. Where is your file and the file type? It will again ask, the first row contains headings. So if you click OK, next it will ask, where is your data? Sheet 1, sheet 2, or sheet 3. So suppose you selected sheet 1 and then you press OK. It will start reading. This is old screenshot. So it will start reading how many records were there in the Excel sheet with the date and time. Now you can see this something written below: read, see, users, biostat, desktop, sheet for analysis. This is if I know the computer language. I can directly use the keyboard shortcuts and do the inputs. It will take the sheet automatically. But we are not IT professionals, so we have to rely on open, browse, window, all those things. Now I want to see variables, so I want to define variables. So I'll click on variables and define and press OK. It will read the Excel sheet inside. It will show now the Excel sheet how it looks. But then I have to close this. Otherwise, I'll not see the back window. So it's like working blind. So once I close this, now next is I want to know how many males and females were there in the study. So I go to frequencies, under statistics frequencies. It will show this new window, and frequency of what? So there will be a drop down, frequency of gender. So you select gender, you will get this male female distribution. Again, if I knew computer language, see here, FREQ space SEX. If you write like this, it will show up the result. But we are not IT professionals. Next, I want to compare the outcome of gender versus erosion. So how many males and females have gender, male female versus erosion, yes or no? So it's called a cross tabulation or table. So this is the 2 by 2 table: 118, 2, 124 and 3, along with the percentage it has given. Now, which test can we apply for 2 by 2 table? Chi-square, very good. And odds ratios? Fisher's exact, very good. And frequency of the cell less than 5? Very good. So all this is applicable. See here, 2 and 3. The frequency of the cell is less than 5. you can go for Yates correction. Very good. 2 by 2 table, first chi-square, and then Fisher's exact, and then odds ratio. So it has given all the answers. EpiInfo is an automated software. It will give one click everything ready. So it has given odds ratio. Are you able to see? Odds ratio. Risk ratio also. Chi-square, corrected, uncorrected, Yates correction, Fisher's exact. Now it is also giving the warning. Frequencies of the cells are less than 5. So chi-square may not be a valid test. So don't see the chi-square value. See the Fisher's exact value. Okay. So it's an automated one. Everything will be ready. But the tables are not very useful. You have to edit the tables in your word processor. Okay. Next, I want to find number of decayed teeth in males versus females. So which test should I use? Male and female are two groups not related to each other. I have given the hint. Not related. Yes, very good. What's the answer? Independent samples t-test, unpaired t-test, student t-test, or simply the t-test. Very good. So here in the table function in mean, I will write mean of decade against I want gender and press OK. Now it will give me the mean in male, mean in female. Along with that, standard deviation, variance, t-test, Anova भी उसने कर दिया, but साथ में उसने warning भी दे दिया that Bartlett's test of inequality of proportions, variances is there. So Anova may not be an appropriate test. It is not an appropriate test. That means it is telling that your data is skewed. Your data is not normally distributed. Don't go for t-test. So it is doing a Mann-Whitney by itself. Am I clear, everyone? Everyone? Can we go ahead?
Yes,
Now I'll
sir.
give you the same examples in SPSS so that we know how the things work. So before we go into SPSS, SPSS has a long history. It's one of the most successful software in the data analysis market. Still better software would be SAS. SAS. The entire pharma industry relies on SAS. But the training is very tough. It's like an IT professional. You have to sit with that and do the coding, and only then you will get the results. It's not very simple. Fine. But if you want to shift your career and become something in pharma industry, SAS training will be very beneficial. Okay. This is the cost of SPSS. The slide was belonging to 2016 and I purposefully did not change since then. So any staff member, what was so special in 2016? Anyone? Anyone? 2016? We all became poor. What happened? भाइयों और बहनों. Yes. Okay. So before that, the cost of this software was $7,820 US. You can read there, premium version per user per year. If you convert this to the Indian website, this was almost 5.5 lakh rupees for one user, 1 year, and 6% of VAT initial, not GST, VAT. Okay, nowadays the cost, if you check now, it is 10.5 plus 18% GST per user per year. And if I'm going to buy, I should buy a premium version. Baki softwares can handle the basic statistics. So if you are buying, you're purchasing, you'll go for a premium version. So the investment is almost 12 to 13 lakh rupees per year per user, which is a heavy, heavy to the pocket. Okay, someone has asked in the chat box the version of EpiInfo. It is currently 7.1.2 or 7.2 basically. It's available free of cost. Okay, now I'll give you a proper demo of SPSS, live demo, not on screenshots. So I have this 17th version and 23rd version also fully licensed. I have prepared few demo sheets. Okay, I'll start sharing my entire screen so that you know what is the software, what is the sheet. Okay, are you able to see my window, my desktop? Are you able to see?
Yes,
Yes,
Should
sir.
I stop my video? Is it interfering? Okay. Yes. Now, this is the demo sheet for SPSS. Okay. So epi sheet, demo sheet formulae, log demo. This is the sheet for SPSS. Just open this and we'll see how the sheet looks like. So this is hypothetical. We have age, gender. Gender I have coded as 1 and 2. Socioeconomic status, decade, missing field teeth. Don't worry, it's a dental example, but it's number. You can also understand. Anyone can understand. Erosion, trauma, height, weight, BMI, colonies, microbial colony. All this I have taken the data. Okay, fine. So I have just opened this window of SPSS. Can you see the heading? Can you see the heading? SPSS Statistics Data Editor. I'll put this sheet from the folder into the software. You can drag this and leave. It will now start reading. So where is your data? So it will ask me where is the data. Sheet 1, sheet 2, sheet 3. So sheet 1. Read the variables names from the first row. Yes, we have utilized only one row for the headings. Press OK. Now it has started reading. In EpiInfo, it was all blind. Sheet dikh nahi raha tha. In SPSS, it is like an Excel. You can work with the sheet. Now, the same statistics we'll use here so that you get the difference. कि EpiInfo में table कैसा था, SPSS में table कैसा. So I want to know how many males and females were there in the study. So I'll go to analyze, descriptives, frequencies of this SEX and write here OK. Can you read the result? Can you read the result for me? Reader, how many males, how many females?
Female 120.
120 females.
Males are 2.
But अभी ये छोटे में लिखा है तो 2, बड़े में लिखा है तो 125. Does it mean different? होता है छोटा मेल बड़ा मेल? नहीं होता. So that means there is some writing error purposefully done for you to understand. I have to convert this to big male here and big male here. And now if I run the frequency, do I get the answer proper?
Yes.
Okay. So this is purposefully done. Like the same example, code, writing small and writing capital earlier. Okay, fine. So this is your result. So how many males and females with the percentage, it has given me the result. Now, next. I want to know in that 2 by 2 table, how many male female have erosion. The same example. Okay. So we'll go to this cross tabulation. The independent factor gender has to be written in the row and the outcome or the disease or the condition has to be written in the column. And we have to go to statistics, chi-square, and we can press OK. But I also want to know the risk as in the odds ratios. And I press OK. So this is the answer. 118 2, 124 and 3 सेम डेटा उधर भी मिला था, इधर भी मिला है. chi-square value, again the warning is there. Frequencies are less than 5. So you have to go with Yates correction. In SPSS, we don't have the word Yates. We have continuity correction. Okay. Now, odd ratio, relative risk. Epinfo ने भी किया था अपने आप से. यहाँ पे भी मिल रहा है odd ratio 1.42 with the 95% range of 0.234 to 8.695. So here we have to put the extra button, hit the extra button. अगर मैं ये risk नहीं लिखता, so it will not give me the data. It will not give the result. For example, if I don't write here in the statistics cells, I don't write risk. It will only give me chi-square value. It will not give the odd ratio. So it's a manual software. जितना मांगोगे उतना ही मिलेगा, extra नहीं मिलेगा. But Epinfo will give you extras because that is fully automated and computerized. Okay. Now next step. There we had found out the mean of decayed teeth in male and female. So to see the mean decayed teeth, what I should do? First see whether the decayed teeth follow normality or not. So how to check for normality of the data? Go to analyze, descriptives, explore the data for suppose decayed, plots, normality plot with a histogram with a stem and leaf. Continue. Okay. Now see the result. So I told you mean देखना है, standard deviation देखना है. So what is the mean? 3.9. Standard deviation 4.7. Is it greater? Standard deviation ज़्यादा होना मतलब your data is very much scattered, very much skewed. That means parametric test के लिए जाओगे या non के लिए जाओगे? Non-parametric. Very good. Excellent. Shapiro-Wilk. P-value highly significant means highly scattered. Again, it proves that your parametric test will fail. Better go with non-parametric. Histogram. Are you able to make a normal curve out of this histogram? ऐसा कुछ बन रहा है? नहीं बन रहा. In fact, ऐसा बन रहा है. Which is again a plateau. Skewed to the right. It's not a normal curve. It's a skewed curve. Next. Can you tilt your neck 90 degree right? 90 degree right को tilt करो ऐसा. You will see the histogram. But again, it is skewed. Next. Are the lines falling on the line or the dots falling on the line? No. QQ plot, RR plot. ये सब मैंने आपको दिखाया था on the slides. So the points are deviating from the line. That means it is skewed. Box and plot does not have a lower end. नीचे का part नहीं है. Again, it is skewed. These are the outliers. What is the conclusion? Decayed as a number is skewed. Skewness means it's highly having extreme values, very low to very high. So should I go with parametric or non-parametric? Should I go with parametric or non-parametric? Non-parametric. So suppose I was to do t-test, जो कि गलत है, but analyze, compare means independent samples, gender or sex I have to code. So मैंने यहाँ पे एक column 1 2 1 2 का बना के रखा, where male is 1 and female is 2, and decayed as the outcome. And I have to define group 1 को मैंने label किया है 1 and group 2 को label किया है 2. Okay. And SPSS आंसर दे देगा मुझे. Mean standard deviation के साथ में p value भी दे दी. But is it good? Is it correct? No. उसने कोई warning भी नहीं दिया मुझे. Your data is skewed. Do not go for t-test. ऐसा कुछ भी नहीं बोला. Did you realize, everyone?
Yes.
Okay. So this is manual. जितना पूछोगे उतना ही मिलेगा. Now I have to go with Mann-Whitney. So analyze non-parametric 2 independent samples. Again, I have to mention the gender coded here and the decade here, and I have to define the groups. 1 को 1 लिखा, 2 को 2 लिखा. Mann-Whitney यहाँ पे टिक मारा हुआ है. Okay. Now it will give the p-value of Mann-Whitney 0.764. Am I clear? Everybody?
Yes.
Okay. So the same thing you have to do with paired t-test also. So for paired, you have to see whether the data is normally distributed or not. And then you decide to go for paired t-test or go for Wilcox. Otherwise, you will go wrong. Why I'm stressing on this? Many of the homeopathy trials I have seen, one group before after using a scale, 30 subjects, but we do not bother about normality. We directly go in for paired t-test. So please correct yourself. अपने आप से करो, no problem, but बराबर से. Am I clear? Everybody? Okay. Should I close this window? Okay. Any doubt till now? I'll just take 2 more minutes, 5 more minutes, then we are done.
Hello, sir.
Yes, madam.
What are limitation of Epinfo app, mobile app?
Okay. Mobile app, ma'am, I have not used very frequently, but overall, I'll tell you the Epinfo as a software on PC does not do a paired t-test. Directly, it will not do a paired t-test, which is, I think, more important in homeopathy. We see before, after the remedy. Okay. And also, Epinfo is not, it's not, the tables are not user friendly. It will export the output in a Word, but the tables do not have borders. So you have to sit back and make the tables by yourself. SPSS, on the other hand, will make tables, but those tables will have extra columns, extra information, which you have to delete. So again, after SPSS also, you have to spend 3-4 hours per client to edit the tables. Getting it? Okay. Can we go ahead? Yes. So this is all demo I have given. Okay. So still, if you are confused, I would encourage you have to take professional help. A statistician should be contacted at the start of the study, even for sample size and for data analysis. Okay. There are various other softwares in the market, MedCalc, GraphPad, WinPeppy. And if you are interested in computer coding as an IT professional, then SAS programming, R and Python are very heavy programs. So there are trainings, and we have lakhs of rupees of trainings on these programs. So these are certain screenshots of the home pages. MedCalc will cost you around 35,000 to 80,000, depends on the package. GraphPad also may cost you in the same range. These are paid ones. Okay, so any doubts? Again, a disclaimer. So I have not shown any of the softwares which are pirated. All are fully licensed to my company Biostat, and we use only the licensed versions, not the pirated versions. Yeah, any doubts?
No, sir.
Okay.
Smita, ma'am. Hello. Hello, Smita.
Hello. Can you hear me? Hello. Can you? Hello. Hello. Am I audible?
Yes, ma'am. Yes, ma'am.
Okay. So, Thank you, Dr. Dheeraj Kalra, sir, for giving your valuable time and sharing your knowledge on research methodology and statistics with our interns in such a detailed way. Our interns must have benefited, and it will be useful for them in preparing their dissertation. Also, our virtual vote of thanks, staff, intern.
Am I audible? Yeah, we have a
Yes,
power
sir. Yes.
failure. Yeah, we got a power failure. Yes. Yeah, but I was able to finish. That was my last slide. No problem. Yeah.
Okay. So I'm again here, sir, Dr. Smita Nair.
Yes, madam.
I thank you for giving your valuable time and sharing your knowledge on research methodology and statistics with our students interns in such a detailed way, sir. And our interns must have benefited, and it will be very useful for them in preparing their dissertations and thesis during internship, and also for preparing for their post-graduation study. So kindly accept our virtual vote of thanks. I, on behalf of Motiwala National Homeopathic Medical College, thank you for giving us this time. Thank you, sir.
Yeah. Thank you, madam. Thank you for connecting with, giving me opportunity to connect with your students. And I would, say from the bottom of my heart, your students are good. They could catch up so nicely, even on a virtual background, on a virtual platform, you can say. They were able to answer all the questions, which I have not seen in, such a virtual platform. Many times we have a limitations, people don't pay attention. They are, sipping coffee or taking breakfast or something. But your students are disciplined. Everyone
Yes,
is, made to sit in the auditorium, nicely organized.
yes,
And
sir.
I was able to teach happily. And so I went on. Even if they were interns, I make sure, it was covered to the depth
Our
because
pleasure,
of
sir.
the interest your students have shown. Thank you. Thank you so much.
Thank you so much, sir. Looking forward for your
Anytime, madam.
coming
Anytime.
webinars also, sir.
Sure,
Thank you.
sure. Yeah. Thank you. Thank you so much.
Thank you so much.
I'll take a leave, ma'am.
Yes, sir.
Thank
Thank
you.
you, sir.
Yeah. All the best, all students. Thank you.